So looking at our exponent rules, our first exponent rule is that when we have a to the power x times a to the power y, we add. So when we have like bases, we add exponents. So that will look like if I had x to the power 2 times x to the power 3, I would then get x to the power 5. Or if I had y to the power, let's say, negative 2 times y to the 6, that will then equal y to the negative 2 plus 6, which then just gives me y to the 4. Understood? Now, if we take this into numbers, which is what we're going to be working with in this section, we're going to be applying the same principles. So let's look at a few with numbers. If I have 2 to the power x times 2 to the power x, I then get 2 to the power 2x. I hope you guys start seeing the idea. As long as the bases are the same. And what is the base? The base is this part right here of your exponent. You can see here, that is your base. The a in this scenario, the 2 in this scenario, those are your bases. Let's move on to the next rule. Now we're going to be working with our division. If I have a to the power x divided by a to the power y, I get a to the power x minus y. So for multiplication, since when we multiply like bases, we add the exponents. For division, we are going to subtract the exponents. So if I have x to the power 6 over x to the power 2, I would then get x to the power 6 minus 2, which would then give me x to the power 4. Working with actual numbers, if I had 2, let's say to the power 3, divided by 2 to the power, let's say 2. Let's look at this. This will allow us to see it a bit better. So here we'll get 8 over 4, which would then give us 2. And if we look at what happens when we work with these numbers, it's the same as saying 2 to the power 3 minus 1, which would then just equal 2 to the power 3 minus 2, which would then just equal 2 to the power 1, which is 2. So you can see it works. These rules work. I'm just going through it to show you so you can get them a bit more intuitively, or if you want to show up any of them, you get them now. Let's work when we have a power of power. I hope you have your calculators ready. So if I have 3 to the power 2 to the power 3, that will then give me 9 to the power 3, which equals 729. Now let's see what happens when we apply this rule. If I had 3 to the power 6, that then equals, put that into your calculator, 3 to the power 6, that also equals 729. So as you can see, this rule works. Let's just see a few examples of what happens when we put them with variables. So if I have x to the power 4 to the 3, that's just going to give me x to the 12. Okay, if I have 2 to the power x to the power 3, that's going to give me 2 to the 3x. It's also important to note that I can work forward and backwards when doing this. So I can convert 2 to the power 3x and look at it as 2 to the 3 to the x. You see that? Either or, depending on what you want to remove as a common factor. And that can then become 8 to the power x. These are all the same. Let's move on to if we have a fraction. So if I have x over y to the power 2. As you can see with our rule here, it will then become x squared over y squared. There's not much explanation into this. You're just applying the power to both of them. When working on this, anything to the power 0 is 1. So if I had a long term like this, x squared plus xy plus 2200 x to the power 0, it just equals 1. Anything to the power 0 is 1. And you don't have to show much working out for that. If you get a test or an exam, it is understood. Now, this is something new. This is when we have a division or a fraction in our exponent. So if I have x to the power 2 over 3, okay, this part right here where we have this 3 in the bottom, we're going to focus on that right now. If I have, let's say, 8 to the 1 over 3, if you put that into your calculator, you'll see it'll equal 2. And what's actually happening here is that we are saying the cube root of 8. So when you have a fraction as your exponent, what you're actually doing is you're applying the root. So for this question here, it'll then become like this. So your numerator, that becomes your numerator, and this is your denominator. Very important to note and understand. Memorize, understand, get this, because when it comes to application, you're not understanding these principles, it's going to be very hard for you. We're now moving on. What happens when we have a negative exponent? When you have a negative exponent, what's occurring is it's going to swap from the denominator to the numerator. So if you look here, I have x to the power negative 1 over 1, and that's just going to swap. So this is going to come to this side to make the exponent positive. So I'm going to have 1 over x. Let's take another example. If I have x to the minus 2 over y to the minus 2, I will then write this as minus 2. I'll put the y squared on top to make it a positive. I will put the x squared on the bottom to make it a positive. Are you guys starting to get the idea here? So if I had 2 over x to the minus 2, that's just going to be, this 2 is going to stay here, to the x squared. Okay, so it's important you guys understand this principle. We are also going to be using it. And then finally,